Hello everyone, welcome to my YouTube channel Tech with Ankush again. So currently I'm covering this course that is Identity and Access Administrator Associate and covering this module that is Implementation and Authentication and Access Management Solution. In the last video I had covered this plan, implement and administer conditional access module. Today I will start this manage Microsoft Entra Identity Protection. So let me start. So, what is Microsoft Entra Identity Protection? Think of Microsoft Entra Identity Protection as a smart security guard for our user accounts in our organization. Its job is to continuously monitor user sign in activities and identify suspicious behavior and help automatically protect accounts before attackers can cause damage. Means this Microsoft Entra Identity Protection, it checks like who the user is login, approve it, plus continuously it monitors like this is the right person and he is doing the right job, or is there any attacks. And why it is important? Imagine someone steals an employee password. Without identity protection, the attacker might successfully log in and access resources. Identity protection helps by detecting suspicious sign-in. Means if there is any suspicious sign-in, means the person is logged in from different location like Russia, China, etc. Identify compromised accounts, automatically responds to risk, helping security teams investigate threats. How identity protection works? Microsoft analyzes over 6.5 trillion security signals every day from Microsoft Entra ID, Microsoft accounts, Xbox, other Microsoft services. Using this massive amount of data, Microsoft can recognize attack pattern and suspicious activities worldwide. When a risk is detected, identity protection can first alert administrators, second block access using conditional access policies, third require multi-factor authentication, fourth ask a user to reset a password, fifth send information to security tools for further investigation. The three main functions of identity protection: first, detect risk automatically. It continuously watches user accounts and sign in for suspicious behavior. Then investigate risk. Security team can review detailed reports in the identity protection portal. Third, export risk data. Risk information can be sent to other security systems such as SIEM like Sentinel Solutions or Defender for advanced monitoring and analysis. Common risk detection explained. Like here are some example of what identity protection can detect. Risk detection type, and these are like description, like anonymous IP address, like sign in from any anonymous IP address, like any anonymous IP location, like Tor browser, VPNs, etc. A typical travel, like sign in from a typical location based on the user recent sign in. Means let us assume recent sign in of user is from India. Within 10 minutes, the user sign in from Russia. So it's a typical location travel. Then malicious IP address, like sign in from a malicious IP address, unfamiliar sign in properties, like sign in with properties we have not seen recently for the given user. Leaked credentials indicates that the user valid credentials has been leaked. Password spray indicates that multiple users are being attacked using common passwords in a unite brute force manner. So there are number of, we can say, risk detection type like NO, malice token, token user, anonymity, suspicious browser, verified threat actor IP, new country, activity from anonymous IP address, suspicious inbox forwarding. So you can go through these, like we can say, slides and read it. Then real world example. Imagine Sarah normally sign in from Delhi, uses a company laptop, uses Microsoft Edge. One day, a sign in occurred from Russia through a Tor browser using a device never seen before. Then here, identity protection immediately identifies anonymous IP address, atypical travel, unfamiliar sign-in properties. So based on company policy, Microsoft can automatically block the sign-in required MFA, force Sarah to reset her password. Then roles and permissions. Not everyone can access identity protection. Security administrator can full access to identity protection and cannot reset user passwords. Security operator, he can view reports, dismiss risk, confirm safe sign in, confirm compromised account. And what he cannot do, he cannot create policies, reset password, configure alerts. Then security reader, he can view reports only, cannot change anything, configure policies, cannot give feedback on detections. License requirement, identity protection requires a Microsoft Entra ID premium P2 license. So this is required. Now, if I go to Microsoft Entra Admin Center, and here is the identity protection. We can see dashboard, risk-based conditional access, risky users, risk workload identity, risky agents. Now, what is available with each license? These are like capabilities, details, Microsoft Entra ID free license or Microsoft 365 apps, Microsoft Entra P1, and here the last one is the P2. Now, capability like risk policies. What is the detail? User risk policy via identity protection. In free, it's not available. P1, it's not available. P2, it has. Then risk policies like sign-in policy via identity protection or conditional access, not available in free, not available in P1, available in P2. Then security reports overview. It's not available in free one, not P2. In P1 not available, P2 it has available. Security reports like risky users. In free plan, limited information, only users with medium and high risk are shown. No details drawer or risk history. In P1, we have limited information, only users with medium and high risk are shown. No details drawer or risk history. In P2, we have full access. Then security reports like risky sign-ins. Here we have limited information in free license. No risk detail or risk level is shown. In P1 license, we have limited information. No risk detail or risk level is shown. In P2, we have full access. Then notifications, user at risk, detected threats, weekly digest or MFA registration policy. It's not available in free. Not available in P1. It's available in P2. That is why we recommend P2 license for Entra ID so that we get more features. Now implement and manage user risk policy. Think of Microsoft Entra ID protection as a security guard for your organization user accounts. It constantly watches for suspicious activities and tries to answer two important questions. One, is this login suspicious? Means this is a sign-in risk. Has this user account been compromised? Means it's like a user risk. What is a user risk policy? User risk policy help identifies whether a user account has likely been hacked or taken over by someone else. That is user risk policy means a user account has been compromised or someone steal the ID and password for this user. Simple example. Imagine John normally log in from India, uses his laptop, works between 9 a.m. to 6 p.m. Suddenly, Microsoft detects John password was found on the dark web. Someone is accessing his account from another country. Unusual activities are happening on his account. So Microsoft assigns a user risk level because it suspects the account may be compromised. The user risk policy then decides what action to take automatically. So this is the user risk policy. Now, what is a sign-in risk and user risk? This is sign-in risk. This is user risk. Differentiate. Look at the specific login attempt for sign-in. looks at the overall user account under user risk. Is this login suspicious? Has the account been compromised? Example, login from strange location. Example, user credentials leaked online. These are example like sign in risk. John logs in from India at 10 a.m. 5 minutes later, login from Russia. So Microsoft flags the login as suspicious. Now, user risk. Microsoft intelligence discovered John password was leaked online or leaked on the internet. The account itself become risky. Why use user risk policies? Without a policy, admin must investigate every alert manually. User may remain compromised for a long time. With a policy, Microsoft automatically read to detect risk. User can fix problems themselves. Security improves while reducing admin workload. What happens when risk is detected? You can configure actions such as required password change. If a user account is considered risky, user sign in, Microsoft detect high risk. User is forced to reset their password. Account becomes secure again. This process is known as self-remediation. Why it is useful? Instead of waiting for IT support, user fix the problem immediately. Business productivity is maintained. Security risk is reduced. Now, prerequisites for self-remediation. Before user can fix their own accounts, they must be registered for SSPR, means self-service password reset, means the user can able to reset their password by your own. Allow users to reset password without contacting IT means. Then MFA, multi-factor authentication, add another verification step as MFA app, SMS code, phone call, etc. Microsoft recommends enabling the combined security information registration experience, where users register both MFA and password reset together. Then choosing risk levels. Microsoft allows organization to decide how sensitive the policy should be. Risk level like low, there are three types: low, medium, high. Think of it like a security alarm. Then high threshold, only very dangerous situation triggers the policy. Advantage, fewer interruption, better user experience. Disadvantage, some suspicious activity may be ignored. And if we use low threshold, even small risk triggers the policy. Advantage, stronger security. Disadvantage, more password resets, more user interruptions. Like we get notifications again and again in low threshold. Microsoft recommend policy, recommend risk level. User risk policy, it's recommended high. For sign-in risk policy, it recommends medium and above. This provides a good balance between security and user convenience. Exclusions. Some accounts should not be automatically blocked. Example, break glass accounts, emergency administrator accounts used when MFA system fail, identity services are unavailable, administrator are logged out. These accounts are often excluded from risk policy because if an emergency occurs, administrator must have a way to access the environment. Important, exclusion should be reviewed regularly to ensure they are still necessary. Means, let us assume these risk policy block the user account, so he can't able to access. That is why we use the break glass account, which do not use the policy, or policy is not configured on that account. This the account use these we use this account in case of emergency. Then trusted network locations. Organization can define trusted locations such as office networks, corporate, VPNs. Microsoft uses these trusted location to reduce false alarms. Example, without trusted location, employees log in from office. Microsoft may see unusual behavior and generate an alert. So with trusted location, Microsoft recognize the office network. Fewer false positive risk detection occur. Now this is the real world scenario. Imagine Sarah password gets stolen. Microsoft detects the leak password. Sarah account receive a high user risk score. The user policy is triggered. Sarah is required to verify her identity and change her password. The risk is remediated automatically. Result, Sarah regains access quickly. The attacker loses access. IT administrator can review the incident later. Then monitor, investigate, and remediate elevated risky users. Think of Microsoft Entra ID protection as a security control for your organization. When it detects suspicious activity, it helps administrators answer three questions: who is at risk? Why are they at risk? What should we do about it? This process is called monitor, investigate, remediate. Step 1: Monitor risk. Microsoft Entra ID protection continuously watches for suspicious activity. When something unusual happens, it records the information in three reports. First, risky user report shows user whose account might be compromised. Example: John password was leaked online. Sarah logged in from suspicious location. The report helps administrator identify which users needs attention. Then risky sign-in report like shows suspicious login attempt. Example: login from unfamiliar country, login from unknown device, impossible travel like India, USA within minutes. This report contains up to 30 days of sign-in data. Then risk detection report shows the specific security events that cause the risk. Example: leaked credentials, anonymous IP address usage, malware linked activity. This report shows up to 90 days of risk detection history. Real life example: imagine you are a security guard. You receive an alert: John account may be compromised. Your first task isn't to block the user immediately. Instead, you investigate: where did the login happen? What device was used? What was MFA completed? Has this happened before? That's exactly what the report help administrator do. Step 2: we investigate the risk. Once a risk is detected, administrator investigate the details. The report provides information such as for risky user, which users are risky, risk history, previous risky sign-ins. Then details of the detection. Administrator can then reset password, confirm compromise, dismiss false alerts, block user access. For risky sign-in, administrator can view risk level like low, medium, high, device used, location, application accessed, MFA details, conditional access policies. Example: a login from Russia may be marked at high risk. The admin can decide whether it's an attacker or legitimate user traveling abroad. Understanding risk level. So Microsoft assign risk levels like low, slightly suspicious, medium, concerning, high, very likely compromised. The higher the risk level, the more urgent the response. AI can correct itself. Sometimes Microsoft AI initially thinks a login is dangerous. Later, it discovers the user successfully completed MFA, the password was changed, the activity was legitimate. In these situations, Microsoft may automatically mark the event as AI confirmed, sign in safe, and remove the risk. Means Microsoft also uses AI tools which detects whether the user or there is a risky sign in or it has been resolved or not. Then step 3, remediate means fix the risk. After investigating, administrator need to remove the risk. Microsoft recommends closing risk events as quickly as possible because attackers can act fast. Method 1, self remediation. This is recommended one. This is the easiest option, requires MFA enabled, SSPR enabled. When Microsoft detect risk, user sign in, user is challenged with MFA, user reset password, risk is removed. No administrator involvement is resolved because user did all the steps by himself. Example: Sarah password appear on the dark web, Microsoft detect high user risk. Instead of calling IT, Sarah verifies the MFA, change her password, regain access immediately. So problem is solved. Then manual password reset. If self remediation isn't available, admin can reset the user password. Two options exist: temporary password, admin generate a temporary password, user sign in and must create a new password. Or forgot password reset, like user is required to reset their own password. This works only if the user has registered for MFA and SSPR. Method 3, dismiss user risk. Sometimes the alert is safe. Example: user was traveling, login location looked suspicious, investigation proved it was legitimate. So administrator can select dismiss user link. Like Microsoft has the feature, it shows this is there is a risk in the user account, but we see no, it's fine. We investigate the risk and we find it's normal, so we will dismiss that alert. So this removes the risk status but does not change the user password. Method 4, Close individual risk detections. Administrator can close specific detections at one time. Actions include confirm user compromised, confirm sign in compromised, confirm sign in safe, dismiss user risk. This help reduce the user overall risk score. What if a user is blocked? Sometimes users are blocked because their risk level is too high. Administrator can unblock them in several ways. First, unblock user risk, like he reset the user password, dismiss the user risk, exclude the user from the policy, disable the policy temporarily. Then unblock sign in risk. A user may simply be logging in from unfamiliar location. Possible solutions: use a familiar device, sign in from trusted location, exclude the user from policy, disable the policy if misconfigured. Then Microsoft Graph integration. Organization can automate investigation using Microsoft Graph APIs. Three important APIs are these are APIs purpose. Risk detection retrieves risk detection events. Risky users retrieve risky user information. Sign in retrieves sign in risk information. Security teams can use these APIs to create dashboard reports and automated workflows. Implement security for workload identities. First, what is a workload identity? Like, most people think of identities as users. For example, ABC or Ankush sign in into Microsoft 365 account using a username and password. That's a user identity. Means I am providing my identity, like I am using my username and password. That is the user identity. But application also needs identity. For example, a backup application needs access to storage account. A web application need access to a database. An automation script needs access to Microsoft Graph. These applications use workload identity instead of user accounts. Now, a workload identity can be service principal, application registration, managed identity. Think of a workload identity as a digital identity used by application instead of a person. Why do workload identity needs protection? Imagine a web application that access customer data. The application stores a secret or certificate so it can authentication. If the hacker steals that certificate or secret, they can access company resources, read data, modify data, impersonate the application. This is why Microsoft extend Microsoft Entra Identity Protection to workload identities. It helps detect and respond to attacks, engaged application and service principles. User identity and workload identity. This is user identity, this is workload identity. Used by people, used by applications. Can perform MFA, cannot perform MFA. Password changed by user, secret often stored in code or vaults. Has HR life cycle, has usually no formal life cycle. Easier to monitor, hard to monitor. Microsoft highlights that workload identities are harder to secure because they often store credentials somewhere and can't use MFA. This makes them attractive target for attackers. Real life example: imagine a company has a payroll application. Normal situation: payroll application uses service principal, access database. Everything works normally. Attack scenario: a developer accidentally uploads the application secret to GitHub. An attacker find it. The attacker now has the permission as the application. This is exactly the type of threat workload identity is designed to detect. Now, requirement to use workload identity protection. To use workload identity risk features, your organization needs Microsoft Entra ID Premium P2. Required roles: the administrator viewing the risk must have one of these roles: security administrator, security operator, security reader. Without these roles, the workload identity risk information won't be accessible. What risk can Microsoft detect? Microsoft Entra Identity Protection continuously monitor workload identities and look for suspicious behavior. Let's look at each detection type. Microsoft Entra Threat Intelligence. So, Microsoft Entra Threat Intelligence. Microsoft Global Security Intelligence detect activity matching known attack patterns. Example: Microsoft sees malicious IP address, known hacker infrastructure, suspicious behavior seen in previous attacks. The workload identity is flagged as risky. Think Microsoft knows this look like an attack because it has been similar attack before. Then suspicious sign in. Microsoft learns what is normal for a application. After observing behavior for roughly 2 to 60 days, it builds a baseline. If something unusual happen later, Microsoft generates the alert. Normally, example, app logs in from India, uses a specific IP address, access Azure storage. Now suddenly app login come from different country, different IP address, different user agent, different resources access. Microsoft flags it as a suspicious sign-in. Think the application is behaving differently than usual. Unusual additions of credentials to an auth app. A new credential is unexpected added to the application. This detection comes from Microsoft Defender for Cloud App. So we have to use this feature. Example, an attacker compromise an application. They secretly add a new secret, new certificate. Now they can access the app anytime. Microsoft detect this unusual credential addition. Think someone secretly added a Sparky to the application. Admin confirmed account compromised. An administrator manually confirms the workload identity has been compromised. Example, security investigation reveals secret stolen unauthorized access occurred. Administrator clicks confirm compromised. Microsoft record this as a risk detection. Then leaked credentials. The application credentials have been exposed publicly. Example, a developer accidentally commits client secret to a public GitHub repository. Means the developer by mistake upload the secret to the GitHub, public GitHub repository. Or data breach exposes credentials, secret appears online. Microsoft detects the leak and flag the workload identity. Think the application password is now publicly available. How does Microsoft protect workload identities? After detecting risk, Microsoft can integrate with conditional access. Conditional access for workload identities. Conditional access acts like a security guard. When Microsoft Identity Protection says this workload identity is risky, conditional access can automatically block access before damage occurs. Example, before protection. Compromised application access database. Result, data theft. With conditional access, compromised application, it marked at risk. Conditional access, it will automatically block the access. So result, attack stopped. What can conditional access protect? Supported single tenant service principle registered in our tenant. So not supported. Third party software as a service applications, multi-tenant application, manage identity. These are currently outside the scope of workload identity conditional access protection. Then explore Microsoft Defender for Identity. What is Microsoft Defender for Identity? Imagine your organization network is large office building. Inside the building, there are employees, computer, server, AD. Now imagine a security camera system that watches for stolen passwords, suspicious login, hacker moving through network inside threats. That security system is Microsoft Defender for Identity. Microsoft Defender for Identity is a cloud-based security solution that helps organizations detect identity-related attacks before attacker can cause serious damage. Why was Defender for Identity created? Many cyber attacks don't start by attacking servers. Instead, attackers often target user account, password, AD. Once they steal credentials, then they try to move through the network and gain more privileges. Defender for Identity helps detect these attackers early. Simple definition, Microsoft Defender for Identity uses signals from your on premises Active Directory environment to detect suspicious behavior, compromised accounts, and advanced attacks. It helps security teams find attackers before they control of the environment. What problem does it solve? Defender for Identity helps security teams monitor user behavior. It learns what normal activity look like. Example, John normally work in India, log in from his laptop, access HR system. Suddenly log in from another country, access sensitive servers, user uses administrator tools. So Defender for Identity notice this unusual behavior. Second, protect user identities and credentials. Attackers often try to steal password, Kerberos tickets, authentication tokens. Defender for Identity watches for these activities and raise alerts when something suspicious occurs. Detect advanced attacks. Many attacks happen in stages. Example: Step 1, attacker steals a password. Step 2, attackers logs into a workstation. Step 3, attackers tries to gain administrator privilege. Step 4, attacker access sensitive system. Defender for Identity help detect attacks across the entire attack chain. Now investigate threats quickly. Instead of searching through thousands of logs manually, security teams get alerts, attack timelines, investigation details. This help analysts understand what happened much faster. Real world example: imagine hacker steals Sara password. The attacker login into the network, try to access domain controller, attempts privilege escalation. Defender for Identity notifies unusual authentication activity, suspicious account behavior, possible credential theft. It immediately alerts the security team. Without Defender for Identity, the attackers might remain undetected for weeks. And how Defender for Identity works: think of it as a three-part system. One, Active Directory, Defender sensors, clouds analysis, security threats. Component 1, Microsoft Defender portal. This is the main dashboard used by administrator and security analyst. Managed through security.microsoft.com. The portal shows security alerts, investigation results, suspicious activity, threat timelines. Think of it as the control room where security teams monitor everything. Now, if I go to security.microsoft.com, so let us wait. So this is the then I can able to access this Microsoft Defender. Then component 2, Defender for Identity sensors. Sensors act like security cameras. They collect information from your environment. Microsoft allows sensors to be installed on domain controllers like on-prem environment. Domain controllers are the heart of Active Directory. The sensors watches authentication request, user activity, network traffic. No separate monitoring server is required. ADFS servers, Active Directory Federation services, allow user to authenticate to application. The sensor monitor authentication events, login activity, network traffic. This helps detect suspicious sign-in. Then component 3, Defender for Identity Cloud Service. The collected data is sent to Microsoft Cloud Service running on Azure. The cloud service analyzes activity, uses AI and machine learning, compares behavior against known attack patterns, uses Microsoft Global Threat Intelligence. Think of it as a giant security brain that constantly looks for attackers. What is Microsoft Threat Intelligence? Microsoft receives security data from millions of devices and organizations worldwide. This creates a massive database of malicious IP address, known attacker techniques, compromised account, emerging threats. Defender for Identity use this intelligence to recognize attack faster. Example: attack detection, normal activity. John sign in from office laptop, access email, works normally, no alert. Suspicious activity: John account immediately log in from another country, attempts administrator action, access sensitive servers. Defender for Identity notices abnormal behavior, possible credential compromise, potential attacker activity. An alert is generated for the security team. Key benefits: visibility, see what's happening inside Active Directory. Threat detection, detect attackers before they gain control. Faster investigation, view incident through a clear timeline. Identity protection, protect user accounts and credentials. Explore the identity risk management agent. Imagine you are a security administrator responsible for 10,000 employees. Every day, Microsoft Entra ID Protection detects suspicious sign-in, leak password, risky users, potential account compromises. Reviewing all these alerts manually would take hours. That is where the identity risk management agent help us. Think of it as an AI powered a security assistant that investigate risky users and recommend what actions administrators should take. It uses a large language model (LLM) to analyze risky users and provide intelligent recommendation before a security incident occurs. Now, why was it created? Like before the agent, risk alert, admin investigates, admin read logs, admin detect action. This process can be slow because it's a manual. So with this agent, risk alert, AI investigates, AI summarize finding, AI recommend action, admin reviews and approves. So what is the result? Faster investigation, less manual work, quicker response to threats. Then prerequisites to use the identity risk management agent, you need Microsoft Entra ID P2 license. Security compute units SUs. The agent consume SU when performing investigation. Think of SU as AI processing credits. Required roles, this is role, but they can rule. Security administrator, start agent, view findings, take action. Security reader, view findings only. Global reader, view findings only. Only security administrator can activate the agent and apply remediation actions. Now, how the agent works? Imagine the agent as a security detective. Every few minutes it asks, did any new risky user appear? Now, step 1, find the new risky user. The agent checks users marked at risk, user inside the scope you have configured. At this stage, no SU are consumed. Example, Microsoft detects Sarah password was leaked, John sign in suspicious. The agent notices both user now at risk. Step 2, investigate the user. Now the agent becomes a detective. It reviews risky sign in, risk detection, user behavior. Questions it asks, why is this user risky? Was there a suspicious location? Was there a leaked credential? Was MFA leak completed? This investigation consumes SUs. Step 3, generate findings. The agent creates a detailed summary. Example, user Sarah, risk level high. Findings, leaked credentials detected, login from unfamiliar location, multiple failed sign in observed. Instead of reading dozen of logs, administrator receives a simple explanation. Recommend an action. Step 4. The agent suggests what to do next. For example, if password was risk, agent give the recommendation reset password. If risk is false positive recommendation, it will dismiss the risk. Think of it as the AI not only finds the problem, but it also provides the solution. Step 5. Answer questions through chat. Administrator can chat with this agent. Example questions, why Sarah was mask risky, which sign in triggered the risk, why do recommend a password reset? The agent explain it reasoning in a plain language. Agent memory, the agent can remember preferred remediation action. Example, your organization prefers leaked credentials, always reset password. The agent remember this preference and apply it in future investigation. Think of it as AI memory for security decision. Now, how to start the agent? Like we have to sign into Microsoft Entra Admin Center. Then we have to go to ID protection, risky users. Then start agent. The agent becomes scanning risky users. Agent settings, administrator can customize how the agent works. Controls, number 1, control, define who can run the agent, who can view findings. Then triggers control when the agent runs continuously monitoring, runs after every 5 minutes. Best for fast detection environments. Daily trigger runs once per day. Best for normal business environments. Manual runs only when requested. Best for on-demand investigation. Scope setting, the agent doesn't have to scan everyone. By default, it scans 100 risky users. Last 90 days. You can customize specific users. Example, only investigate finance department users. Specific user only investigate administrator. Risky user, low, medium, high risk, all risk levels. Time range, we can select 7 days, 30 days, up to 90 days. Notification, like we can choose who receive agent reports like security team, SO analyst, security manager. After each run, those users receive updates. Understanding the agent finding report. After completing an investigation, the agent displays its finding. Agent summary, this is the dashboard overview shows recent investigation, agent activity, quick actions, chat with agent. Think of it as AI assistant homepage. Agent suggestion, the agent highly highlights risky users and recommend actions. Current actions include dismiss risk when use when the risk is false positive. Then reset password use when compromise is suspected. Example, Sara risk level high. Recommendation reset password. The administrator can apply the action directly. Risky user tables list all risky users. For each user, you see risky level finding recommendation. So here, like risk level high, reset password. John, risk level low, dismiss the risk. Risky user details. Selecting a user opens a detailed investigation page. Basic user information, source, username, UPN, current risk level, agent findings. The agent gives a verdict like compromised or not compromised account. Risk summary, a detailed explanation of what happened, why the user is risky, which activities trigger the alert. Risky factors highlight the most important indicators. Example, leaked credentials, unused location, suspicious sign-in behavior. Suggested remediation provides a one-click action such as reset password or dismiss risk. Real world example, imagine Sarah password appear in a data breach. Without agent, security admin open logs, investigate sign-in, review alerts, decide what to do next. Then time 13 plus minutes. With agent, the investigates automatically, finding risk high, reason, leaked credentials detected, suspicious sign in from, like these can be regions, and recommendation it will give reset password. So it's very less time consuming. So that's all for the theory part, and now I will perform the lab. So now I will perform the lab, like how we will enable user risk policy and sign in risk policy. So let me start. So first of all, I have to go to here identity protection, then dashboard. Under dashboard, I can see conditional access, user risk policy, sign in risk policy. So how I can enable user risk policy? First, I click on here. Then policy name, user risk remediation policy. And this is important. The risk policy is now read only and will be retired October 1, 2026 to manage and or modify, migrate to conditional access. Means currently these sign in policy and user risk policy is only on read only mode. We can see what it is doing, but it will get retired on October 1, 2026. If we have to enable this policy, I have to do it under conditional access thing. So let me show you how we will do it earlier. So like risk users, I can select here any user. Let us assume there is a group and I am applying the policy on that group. So let us assume I am applying this policy on SSPR. User risk level, I can select medium and above. Conditional access, like block access, or I can select here allow access, required password change. So this way we can enable the user risk policy or sign in risk policy. I can enable it here. Same thing. So it's under the read only mode. So here if I select here low and medium, and here for sign in risk policy, it requires the MFA. So this way we can enable the policies. And nowadays, if we have to enable the user risk policy, sign in policy, what I have to do, I have to go to conditional access. Then I will create here new policy. I can type it here user risk policy. Then user and agent, I can apply it to all users or a particular group. So let me select the group SSPR test. Then here I can select target resource. So let me select here all cloud apps. Then network, I can configure the network part like all trusted network and or selected network and location. I can do that. Then resources, I have selected. Conditions, I can select the condition like sign in risk level is likelihood that the sign in session is compromised. So I can also configure this thing. Or insider risk device platform location. Then access control, like I can enable, grant or block. So here I can do one thing for like user risk policy. What I will do, I will simply select the password change. Means the user can able to do the password change and this is automatically selected. Like he has to do password change plus MFA. Then this policy will work. And I can simply enable this policy. So this is the way we can enable the user risk and sign in risk policies. Now, one more thing is there under ID protection. Like we can also enable this multi-factor authentication registration policy. So here I can select the user or group. Like let me select the group, this one, and I can enable this require Microsoft Entra ID multi-factor authentication registration. So multi-factor authentication registration policy only affects cloud-based Azure multi-factor authentication. If we have multi-factor authentication server, it won't be affected. So in this way, we can enable this MFA registration policy. And here we will get once we will configure the policy, here we will see the risky agents, risky users, percentage of risky user at each risk level. I can say it's no risk. Currently there are 12 users and both all are secure. Then I can see risky workload identities, like any application that gets the access to other resources on Azure or any other apps or services. Then risky sign in, I can see here, like it will generate the report. Then risky detection, I can do that. Then settings, user at risk detected alerts, I can select that. Then so these are the options come under ID protection. So that's all for today. In the next video, I will cover the theory and lab part for implement access management for Azure resources. That's all for today. Thank you and have a wonderful day.